Okay, today we will discuss the distributed database design, and in distributed database design, there are 6 fundamental issues which we have to tackle, which we have to address while we are going through with the requirement analysis for any given problem. Number one, the first question which we have to respond to is why fragment at all? Means, is there really a need of fragmentation or there is no need of fragmentation? So if there is no need of fragmentation, then there is no need to go for distribution of data. So first question is, while you are determining the requirement, there you have to decide that is the fragmentation is necessary or not. In the second question you can see is about how to fragment. So let's suppose it is decided in the one that the solution is based on the distribution, the solution is based on the fragmentation. Then the second question is that, okay, how will do that? Sorry, how you will fragment it, how you will break it. That is the question which is important. And for that purpose, you need to have a strategy. And based on that strategy, either you will go for vertical fragmentation or you will go for horizontal fragmentation. Again, it depends on the given requirements, or it depends upon the given situation or the given mini world problem, that how to fragment. And for that purpose, further you need some methods, and we will discuss those various methods in this chapter as well, that how you can distribute the data. So let's suppose if you go for horizontal fragmentation, what are the methods which are available? If you go for vertical fragmentation, what are the methods which are available to fragment it? Number three, fragmentation is okay, fine, it is done, but how much to fragment? Or in other words, how much to distribute? Because when you say you go for the distribution, तो फौरन सवाल ज़हन में आता है कि distribution कितनी होगी? Let's suppose you break the data into three, for instance, into three subviews, or you want to break it in 5 subviews or 7 subviews or 8 subviews. So it all depends upon that how you go for the how much you go for the fragmentation, because you need to determine the optimal fragmentation. तो हम तो ऑप्टिमल लेवल पे जाना चाहते हैं ना, हम ये नहीं जाना चाहते कि बहुत ज्यादा ब्रेक करते, बिकॉज एक प्रॉब्लम है वो ये है कि जब हम बहुत ज्यादा फ्रैगमेंटेशन पे जाते हैं या हम बहुत ज्यादा डिस्ट्रीब्यूशन पे चले जाते हैं, तो उसमें बार दफा परफॉर्मेंस एनहांस होने के बजाय परफॉर्मेंस डिक्लाइन भी हो सकता है। आपका मॉडल जो है ना वो हो सकता है वो मॉडल जो है ना वो सस्टेन ना करे। So we need to determine the optimal level for the fragmentation. Number 4, okay, let's suppose you have decided for the fragmentation, you decided how much to do, and then number 4 is that whatever fragments you have created, then you have to check those fragments, and that is called the correctness test or test of correctness. How to test correctness means whatever the fragments you have created, then you will apply 3 conditions on those fragments, 1, 2, and 3, which we will discuss in the next coming slides. So then if all these 3 conditions applied can be, if you apply those 3 conditions to a fragment and they obey that these 3 conditions, it means that they have passed the correctness criteria. Number 5, how to allocate. Now, how allocation will be done? Distribution is one thing, but how you will allocate it? कौन सी resources कहाँ रखोगे, कौन सा data source किधर रखनी है, इनकी allocation का model क्या होगा? And last is, you need some information requirements. Without that, you cannot do it. So you need some information. regarding the data, regarding the schema, regarding the access pattern, so on and so forth. So you need information requirement. Without that, it cannot be done. So these are what? These are the 6 fundamental questions, and in the coming slides, we'll try to answer all these 6 questions. No one can't we just distribute relations? ओके जरूरी तो नहीं है ना कि डिस्ट्रीब्यूशन हर जगह हो रही हो. बात जगह जिस मॉडल को हम डिस्कस कर रहे हैं हो सकता है वहां डिस्ट्रीब्यूशन एप्लीकेबल ना हो, ना करें. ओके फाइन. लेकिन यस, इफ डिस्ट्रीब्यूशन इज नेसेसरी and we are talking about the relational database environment, so always remember that the reasonable unit of distribution in the relational model is relation itself. What we call a relation is a table. So what then it means distribution means that you have to break the relations, and when you break the relations you will come out with subset of the relations, or you will come out the sub relations, whatever you want to say. Sometimes we also say it subviews. So रिलेशन हमारा क्या है? एक फंडामेंटल यूनिट है, बेसिक यूनिट है, रीजनेबल यूनिट है. किसका? रिलेशन डेटाबेस एनवायरनमेंट का. तो इफ वी वांट टू ब्रेक दैट डेटाबेस, इट मींस that we have to break the relations, and when we do this we call it sub relations. And when we have the sub relations, then there will be 3 things. Number 1, concurrent execution of a number of transactions that access different portion of a relation. Yes, so obviously we are talking about an application where we have a concurrent access. People will have various queries and that can be applied on the sub relations concurrently. Yes, this is true. मतलब ये नहीं है कि हमने ब्रेक कर दिया तो अब वहां सिक्वेंशियल होगा. सिक्वेंशियल नहीं होगा, वहां कंकरेंट एक्सेस अलाउ है. नंबर 2, views that cannot be defined on a single fragment will require extra processing. Very clear. Let's suppose if you generate a query and that query only refers to one sub relation, then there will be no communication among those sub relations, and obviously you will have your result or you will have your output without having extra communication. But let's suppose you have generated a query or an application which involves 3 sub-relations or 4 sub-relations or 5 sub-relations. It means it involves the data which is there in the 5 sub-relations. So it needs an extra communication. So over a network, that communication cost does matter. And actually, whenever we compute the cost, that cost depends on the basically on the that cost basically depend upon the extra communication that is being done on the network side. Last is semantic data control. When we have various sub-relations, then we need to have a semantic integrity or semantic data control, because हमने रिलेशन को ब्रेक तो कर दिया है, लेकिन वो रिलेशन है तो एक था ना, हमने डिस्ट्रीब्यूट कर दिया. तो अब ऐसा तो नहीं हो सकता कि उनके दरमियान जो इंटीग्रिटी है या उनके दरमियान सिमेंटिक चेक जो है या इंटीग्रिटी चेक जो है ना, वो हम निकाल लें. अगर वो निकाल लेंगे तो फिर तो ये जो है ना उसमें कंसिस्टेंसी नहीं रहेगी और वो रिलायबल भी नहीं रहेगा. तो इसका मतलब है वी हैव टू हैव the semantic integrity control or semantic integrity enforcement. For example, we have the employee relation, we break the employee relation into employee 1, employee 2 and employee 3. So since they were basically they were the part of the main relation, so that they must have some sort of integrity or some sort of data control within them, ताकि कोई ambiguity create ना हो और वो connect हो एक दूसरे से. तो आमतौर से जो है, अगर हम मुख्तलिफ रिलेशंस में ब्रेक करते हैं हॉरिजॉन्टली, तो हॉरिजॉन्टल जब हम ब्रेक करते हैं तो जाहिर बात है वो डिफरेंट रोज हैं, डिफरेंट रिकॉर्ड्स हैं, डिफरेंट टेबल में एग्जिस्ट करती हैं. और इसी चीज को जब हम वर्टिकली ब्रेक करते हैं तो इसका मतलब होता है जो की होती है उसको रेप्लिकेट करते हैं हर टेबल में, ताकि इनके दरमियान की इंटीग्रिटी मेंटेन रहे. You can see yourself here on this slide that is horizontal slicing, and you can see that we have a project relation, for example, over here, and in the project relation we have the 5 records, and we just want to have the horizontal slicing based on the given information. And what is that given information? That we need to distinguish among two types of projects: projects with budget less than 200,000 and project with budgets greater than 200,000. So you can see based on this condition, these conditions, you can see yourself that project 1 and project 2 are created. And on in this slide you can see that project 1 has only two uh, uh, rows or records, and project 2 has three records, you can see. And this is called horizontal. Now this is called vertical slicing or vertical fragmentation. So in vertical fragmentation, as you know, the fragmentation is done based on the distribution of attributes. So here you can see that we have various attributes, like in the project we have the P name, budget, and location. And you can see the budget is now separated from P name and location. So now we have two relations, project 1 and project 2, based on the vertical slicing. And whenever you are doing this vertical slicing, the key of the table, of the key of the relation, replicates in all these sub relations. तो अगर ये तीन रिलेशन होते तो तीनों में पी नंबर होता, ये चार होते तो चारों में पी नंबर सेम होता, सेम अवेलेबल होता. And obviously that semantic data control can be managed by this key. Degree of fragmentation, that means how much you want to fragment. Degree means how much you want to fragment. Let's suppose in the previous example you have distributed the project relation into two sub relations, so your degree is 2. Let's suppose you want, if you break this into 3 sub relations, then the degree will be 3. Similarly, if you break it in 4, then degree will be 4. And similarly, if you break it into n sub relations, the degree will be n. So here you can see degree of fragmentation. So there are two cases. Either you talk about the horizontal slicing or you talk about the vertical slicing. So in case of horizontal slicing, the worst case scenario is that your number of relations equal to number of records. तो 10 रिकॉर्ड हैं तो आप हॉरिजॉन्टल स्लाइसिंग करेंगे तो वर्स्ट सिनेरियो क्या बनेगा? 10 रिलेशन बना सकते हैं आप सब रिलेशन. मैं ये नहीं कह रहा कि आपने बनाने हैं. No, in normal situations we avoid this because too much fragmentation leads to bad design. So we have to come out with an optimal way to determine the degree of fragmentation. But I'm just giving you an example. The worst case scenario is that if you have all 10 rows, means 10 sub relations. और कम से कम क्या हो सकती है? The minimum is 2 or more. So अगर हम एक रिलेशन को दो में ब्रेक कर रहे हैं तो ये सबसे कम डिग्री हो सकती है, लेकिन ये फ्रेगमेंटेशन है. तो और सिमिलरली इफ वी आर टॉकिंग अबाउट एट्रीब्यूट्स, so let's suppose I have 8 attributes. When I say attributes, normally I refer to those attributes which are called non-key attributes, because key is always replicated. तो key तो replicate होती है, तो मैं non-key attributes की बात कर रहा हूँ. तो non-key attributes जितने उतने आपने vertical slicing कर दी. ये worst case scenario हो सकता है. और best case scenario क्या हो सकता है कि उस relation को आपने दो relation में break कर लिया. But what you have as a database designer, as a person who is basically involved in the design of the database, आपने क्या करना होता है? You have to determine the best level of alternatives, or you will come out the suitable level of partitioning within this range, जो आपको best या optimal results provide करे. Okay, ji. We talked about the correctness of fragmentation. To check any fragment, that whether that fragment is correct or it's valid, we have three things to consider. Number one is called completeness. Number two is called reconstruction, and number three is called disjointness. So what completeness says? The composition of relation R into fragments R1 to Rn is complete if and only if each data item in R can also be found in some Ri. बहुत आसान सी बात है. That what completeness says that let's suppose if you have decomposed a particular relation, जितने में चाहे decompose कर दें, 2 में, 3 में या n में, कहता है complete कब होगा? When it will be complete. कि अगर कोई भी ऐसा डेटा आइटम जो ओरिजिनल R में था, उसको किसी न किसी RI में जरूर होना चाहिए ना. जैसे अभी हम प्रोजेक्ट 1 को देख रहे थे, तो देयर आर 5 प्रोजेक्ट्स. So when we make the sub relations, so उन 1 से लेके 5 तक अगर मैं 1 को ढूंढूं तो 1 भी अवेलेबल है, 2 को देखूं 2 भी अवेलेबल है. ऐसा ना हो कि उसमें कोई एक ऐसा कोई रिकॉर्ड हो जो अब सब रिलेशन में आ ही नहीं रहा. अगर ऐसा है तो इसका मतलब ये होता है कि it is not fulfilling the completeness criteria. That is the first criteria we have. The second criteria is reconstruction. If relation R is decomposed into fragments, then there should exist some relational operator such that कि हम उसको reconstruct कर सकें. तो यहाँ पर एक ऑपरेटर आपको दिखा रहा है ना, नजर आ रहा है स्क्रीन पे, ये ऑपरेटर है. एंड व्हाट दैट ऑपरेटर टास्क, मतलब क्या है इसका? जैसे अभी हमने प्रोजेक्ट से प्रोजेक्ट 1 और 2 बनाया था, तो अगर मैं ये वाला ऑपरेटर प्रोजेक्ट 1 और 2 पे अप्लाई करूं, तो देन आई विल गेट द सेम रिलेशन प्रोजेक्ट. या मैंने एम्प्लॉय को ब्रेक किया था एम्प्लॉय 1, 2 और एम्प्लॉय 3 में, और एम्प्लॉय 1, 2 और 3 पे जब मैं रिकंस्ट्रक्ट लगाता हूँ और तीनों को वापस कंबाइन करता हूँ, देन आई मस्ट गेट द ओरिजिनल एम्प्लॉय टेबल जो जिससे मैंने ब्रेक किया था. पता ये चला कि अगर मैं उनको रिकंस्ट्रक्ट करता हूँ और कुछ रोज मुझे नहीं मिलती हैं, या कुछ कॉलम मुझे नहीं मिलते हैं, या कुछ डेटा आइटम्स अवेलेबल नहीं होते हैं, तो इसका मतलब है कि रिकंस्ट्रक्शन फेल्ड हो गई है. So that is called the reconstruction criteria. Third is called disjointness. Disjointness means, in other words, mutually exclusive. क्या कहता है? Relation R is decomposed into fragment R1 to Rn and data item Di is in Rj, then Di should not be in any other fragment. सीधी सी बात है. क्या कह रहा है? कह रहा है अगर आपने जैसे प्रोजेक्ट को प्रोजेक्ट 1 में और 2 में ब्रेक किया, तो जब आपने ब्रेक कर दिया तो फिर ये नहीं हो सकता कि जो P1 है वो जो प्रोजेक्ट 1 है उसमें भी P1 हो और प्रोजेक्ट 2 में भी P1 हो. नहीं, ऐसा नहीं हो सकता. If relation is decomposed into the fragments, then that particular data item of जो भी है that should, अगर वो Rj में है तो फिर वो दूसरे में नहीं हो सकता. अगर वो R1 में है तो फिर R2 में नहीं हो सकता. R2 में है तो R3 में नहीं हो सकता. अगर ऐसा हो रहा है तो फिर it means it is violating the disjointness criteria, or it means it is not mutually exclusive. बल्कि वो mutually exclusive नहीं हो गए, बल्कि वो overlapping हो गए, तो गलत हो गया. overlapping नहीं होना चाहिए. हमेशा जब भी हम fragmentation करते हैं उसमें overlapping नहीं होती है. fragmentation हमेशा क्या करती है? break करती है relations को. Allocations, alternatives. So there are various ways by which we can think about alternatives. Number one, which is of course related to partitioning, division, fragmentation, which we are discussing right now. And if we are talking about pure partitioning, it means we are not talking about replication. So that criteria comes under non-replicated. And whatever the fragment is, that will be available on only one site. Then there is no concept of this availability of the same fragment on the other side. That is the first thing, that is called non-replicated, or normally you call it partitioned or fragmented. Or number 2 option is allocation, alternative is replicated. Bilkul, that is one of the option you have. If you go for replication, then it means you want to place the same data item, or you want to place the same database, or you want to save the same relation into 2 or more places. तो अगर एक ही जगह पे रखना, 2 जगह पे रखना चाहता हूँ, वो replication कहलाती है. Let's suppose if my data is available on the main server, then I want to create a replica on the other server. Let's suppose that other server is in any other location. So normally why we do this? Because we need to have a good backup of the data, because we know that in any given situation there is always a probability that the systems might fail, and if the system fails, it means you might have problems in your transactions, or your 24/7 operations will be disturbed. So normally people go for replication so that they can sync the data, and if there will be if there is any problem or an issue in the on the network or on the server side, so what they do, it is possible to to uh, to make that data available for the users from the replication site. अब दो options हैं, either you go for full replication, अभी जो मैंने एग्जांपल दी थी ये full replication है कि मेरे पास एक simple client server application चल रही है, मेरा main data server है, and I have created a replica somewhere else. ये क्या है? Pure replication है, full replication है. And what is partial? Partial replications कब होती हैं? जब मैं part of the data को मैं replicate कर रहा हूँ. Let's suppose I have created 3 fragments, but जो 2 fragment हैं उनको उनका replica नहीं ले रहा, खाली एक fragment 1 का replica ले रहा हूँ according to the given situation. That is called partial replication. दोनों चीजें possible हैं. How you will decide as a database designer that what is more suitable in the given circumstances? Let's suppose if you have this question in your mind, how you will analyze it. Of course, whenever you are doing this process, you might have a lot of data with yourself, and you to decide that what to do. But there is one rule of thumb as well, and that says that in any given scenario, please check that how much content is based on read-only data or read-only queries or such applications and update queries. If that ratio is very less than 1, if that ratio of the read-only to the update queries is much less than 1, then replication is advantageous, because if that ratio is 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 very less than 1, it means that you have more read-only queries, and that replication might be suitable in the given circumstances. Otherwise, it will create issues. Otherwise, it will create trouble for you, because replication takes time, and whenever you go for the sync operation, it always takes time. So then it will slow down the process. So in that particular scenario, the replication is not recommendable as a solution for the distributed database. These are the alternatives we have as far as the comparison is concerned between replication alternatives. So you can see there are 3 possibilities which we have discussed. Number 1, हमने उल्टा पढ़ा था. नंबर 1 पार्टीशनिंग थी, फिर हमने पढ़ी थी फुल रेप्लिकेशन, फिर पार्शियल. यहाँ पे हम पहले कॉलम में फुल रेप्लिकेशन को देख रहे हैं, दूसरे में पार्शियल रेप्लिकेशन, एंड द थर्ड वन इज पार्टीशनिंग, जिसको आप फ्रेगमेंटेशन कहते हैं. और लेफ्ट हैंड साइड पे वी हैव सम फंक्शंस, important functions of the database. Number 1, query processing. Number 2, directory management. Number 3, concurrency control. Number 4, reliability. And number 5, reality. So in query processing, full replication में कोई problem नहीं है, because we have a complete replica of that particular data. So then there will be no problem in the query processing. And as far as if you talk about partial replication and partitioning, both have the same difficulty level. As far as directory management is concerned, in full replication, there is no such need of directory management. Why? Because the all data is available at one site. Directory management जो हम रेफर कर रहे थे, हमने पीछे आर्किटेक्चर में भी रेफर किया था, उस वक्त इम्पोर्टेंट होती है जब डिस्ट्रीब्यूशन हो, क्योंकि डायरेक्टरी ही से मुझे पता चलता है कि ये मेरी एंट्री किधर एग्जिस्ट करती है. तो फुल रेप्लिकेशन में तो उसकी जरूरत भी नहीं है, आसान है. एंड बट इन केस ऑफ पार्शियल and partitioning, the difficulty level is same. Concurrency control या जो आप कहते हैं पैरेललिज्म जो कि एग्जिस्ट करता है इन केस ऑफ फुल रेप्लिकेशन, इट इज मॉडरेट, बिकॉज जो है इतना ज्यादा काम ही नहीं है फुल रेप्लिकेशन में अगर आप देखें ऐसी कंट्रोल, इसलिए हम कहते हैं इसको मॉडरेट. But in case of partial replication, yes, it is difficult. Why? Because you have various fragments, but out of those fragments, you have replicated only few. So it is always difficult to manage because you have multiple fragments as well as the replication. So of course, that is difficult to manage. In case of partitioning, that concurrency control is easy because you can implement this by using your directory management or by using your global conceptual schema as we have discussed earlier on, and the local conceptual schema, and with the semantic data control. By help of these three things, yes, it is easy in case of partitioning. Reliability. What reliability refers to? Reliability refers to a system or a device where we have failure free operations. तो जितने ज़्यादा फेलियर फ्री ऑपरेशन के साथ कोई भी सिस्टम, कोई सॉफ्टवेयर, कोई एप्लीकेशन, कोई हार्डवेयर वर्क करता है, उसी से हम उसकी रिलायबिलिटी को मेजर करते हैं. एंड इफ एनी सिस्टम हैज लेस रिलायबिलिटी, देन ऑफ कोर्स the users will avoid this. The users will not use those systems. Okay, if you take any particular hard device and you think it is not reliable, obviously you'll not use it because in your opinion it is not reliable. So reliability is a very key factor. Let's suppose if you are building database applications, the reliability needs to be very high because we are all depending on the data which is there. We are all depending on the queries which we generate, and we see what are the output which are being generated. So in case of full replication, the reliability is very high. In case of partial replication, the reliability is high. In case of partitioning, the reliability is low. So reliability, because in phase of full replication, reliability क्यों हाई होती है? इसलिए हाई है कि मेरे पूरी डेटाबेस एक जगह रखा हुआ है, उसकी फुल रेप्लिका मैं बना रहा हूँ, तो फेलियर का चांस बहुत कम हो जाता है ना, तो ये इसलिए इसमें रिलायबिलिटी हाई हो जाती है. पार्टीशनिंग के केस में लो क्यों लिखी हुई है? बिकॉज यू हैव पार्टीशनड इट. So if any one of the side fails, of course, the system will not give you support. So of course the reliability low हो जाती है, लेकिन इसको हम कैसे बेहतर कर सकते हैं ये हम बाद में देखेंगे. रियलिटी, यानी अब आप रियलिटी का मतलब ये है कि ये सब डिस्कस तो कर रहे हैं, लेकिन रियल सिचुएशन में क्या होता है? फुल रेप्लिकेशन बिल्कुल आमतौर से अक्सर हम लोग फुल रेप्लिकेशन इस्तेमाल करते हैं. पार्शियल रेप्लिकेशन रियलिस्टिक है, लेकिन वैसे मैं आपको बताऊं कम इस्तेमाल होती है. पार्शियल रेप्लिकेशन हम ज्यादा यूज नहीं करते हैं. आमतौर से या तो फुली रेप्लिका क्रिएट करते हैं, या फिर जितने भी फ्रेगमेंट्स हैं उनको अलग अलग हम रेप्लिका क्रिएट करते हैं. और पार्टीशनिंग ऑफ कोर्स इज अ पॉसिबल एप्लीकेशन. बहुत जगहों पे फ्रेगमेंटेशन हम इस्तेमाल करते हैं, यूज करते हैं. अच्छा जी, इंफॉर्मेशन रिक्वायरमेंट्स. So there are four categories which you have to consider in terms of information requirement. You need to have the database information. Yes, you need to have the database information. Let's suppose if you are designing such an application, you must have the database information with yourself. Number two, application information. What type of applications going to be run on that particular database? Number three is of course the computer network information. What type of network is this? अगर आप कहीं जाएं, सर्वे करें, किसी को सोल्यूशन प्रोवाइड करने जा रहे हैं, तो आप क्या करेंगे? एनालिसिस करेंगे या नहीं कि भाई नेटवर्क किस तरह का है? ओके, डेटाबेस तो रन कर रहे हैं, इनका नेटवर्क का इंफ्रास्ट्रक्चर क्या है, ठीक है, कितने लोगों को सर्विसेज प्रोवाइड कर रहे हैं, इनके कितने यूनिट्स हैं, कहाँ कहाँ हैं, मतलब है कि अपने बैकबोन क्या यूज कर रहे हैं, कनेक्टिविटी किस पे यूज कर रहे हैं. क्योंकि क्यों क्यों ये इम्पोर्टेंट है? व्हाई दिस इज रेलेवेंट? बिकॉज दिस इज रेलेवेंट बिकॉज व्हेन यू कंप्यूट द कॉस्ट, ऑफ कोर्स द नेटवर्क डज मैटर. ठीक है, अगर नेटवर्क मेरा सपोर्टिव नहीं है with respect to my application or with respect to my database or with respect to the user queries, so obviously my network will not respond to the people in the optimal time. Or last is computing machines हम जो इस्तेमाल कर रहे हैं, सर्वर मशीन जो इस्तेमाल कर रहे हैं, उनकी क्या एबिलिटीज है, बिकॉज ये सारी चीजें मेरे लिए इसलिए इंपॉर्टेंट हैं कि विदाउट दिस आई कैन नॉट मेक अ डिसीजन। हम डिसीजन नहीं मेक कर सकते कि क्या होगा। when we come towards fragmentation, as we have discussed earlier on, that there are two types of fragmentation. One is called horizontal fragmentation, which means horizontal slicing. And normally, whenever we do horizontal fragmentation, it means you divide the relation into sub relations, uh, और बेसिकली जो ब्रेकअप हम क्रिएट करते हैं दैट इज बेस्ड ऑन द रिकॉर्ड्स। तो एक कुछ रिकॉर्ड एक रिलेशन में आ जाते हैं, कुछ रिकॉर्ड दूसरे रिलेशन। व्हेन वी गो फॉर वर्टिकल फ्रेगमेंटेशन, तो कुछ एट्रीब्यूट एक रिलेशन में आ जाते हैं और कुछ एट्रीब्यूट दूसरे रिलेशन में आ जाते हैं या तीसरे रिलेशन में आ जाते हैं। दैट इज कॉल्ड वर्टिकल फ्रेगमेंटेशन। एंड व्हेन वी टॉक अबाउट हाइब्रिड, hybrid means both. It means you might have the horizontal fragments and you also have the vertical fragments. So it is possible that you have both the fragments with yourself. So एक ही scenario में we might have the horizontal fragmentation and we also have the vertical fragmentation. अब हम discussion को we can move on further. So if we extend our discussion further, the horizontal fragmentation is further divided into two types of fragments of fragmentation. One is called THF and second is called DHF. THF refers to primary horizontal fragmentation and DHF refers to derived horizontal fragmentation. So now we will discuss these two fragmentations in the next lecture. Thank you. I'll send you the link of the next chapter.